Hello, 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 everybody, and welcome to Mixed Reality Dev Days. The topic for this session will be hashtag open, deploy everywhere with OpenXR and MRTK3. I am Roger, joined here by my co-host, Curtis.
Hey, I'm Curtis Evely. I'm a senior software engineer on the MRTK and middleware team. I have been involved in MRTK and sort of HoloLens and mixed reality since for, I don't know, seven or 8 years now. It's been a while since sort of the early days of the beginning of Holo Toolkit, Holographic Academy, all through MRTK2 and now MRTK3. I spend my time these days thinking about kind of the whole development stack. I work a lot on the mixed reality OpenXR plugin and generally working on our OpenXR integration into Unity, just Unity's sort of general integration for, UWP for HoloLens 2 and that sort of thing. And of course, MRTK.
And hey, I'm Roger. I mostly have been working on our platform support in the recent times. On MRTK2, I was one of the key players in trying to get our MRTK2 support for the Oculus Quest. MRTK3, I'm doing a lot of the same thing, making sure that we work nicely on Quest, HoloLens, all the platforms you may want to support and support in the future, and as well as just making sure that we don't have as many regressions in those products as well. But
so yeah, you've probably seen this page a couple times so far over these couple of days. Just talking about sort of the core foundational pieces that we chose to build MRTK3 on. In this talk, we're going to be really focusing on kind of one piece of the puzzle, and that's OpenXR. You may have attended, I think we had a session yesterday specifically around kind of the OpenXR runtime roadmap and a little bit about our roadmap on the mixed reality OpenXR plugin into Unity. This session, we're going to dig a little bit deeper into the integration that exists today and sort of the extension points that both Unity and we have created to better extend MRTK3, basically. Kind of some of the pain points of extending MRTK2 with regards to input, we feel like is a much better story in MRTK3. Just quickly, in case you haven't heard about OpenXR, this sort of mission statement is up here. You can read that if you want, but really what that means for you is kind of a consistent deployment pipeline that supports. You can write your code once against sort of one API set, and you can depend on the runtimes and the devices and the vendors to build in that support and allow your app to be successful.
so yeah, we should, as with all great things, looking back helps us look forward. And what better way to look back than covering how it used to be? So back in MRTK2, if you wanted to deploy on a different platform, it was actually a quite involved process. Unity went to a pipeline called the XR pipeline, and with that, a lot of developers were able to sort of plug into a common interface in order to, say, okay, here's how the device is supported. However, even though there was this like underlying backend, you usually still had to download a separate Unity package per platform, right? So for Windows devices, there was the Windows XR plugin. For Oculus, they ended up making an Oculus XR plugin. And importing packages is never super fun. You always have to keep those up to date. So that was one pain point. And even after you got those Unity packages installed, oftentimes you'd be required to download even extra packages, whether from the asset store or from the developer site themselves. These would result in extra configurations you have to deal with, maybe some extra assets that you never really asked for, but are included in that package anyways, and you have to now manage and figure out, okay, what do I do with this? And those sites also had lots of potentially conflicting setup information because these asset store packages were intended to just kind of work out of the box on their own, but they were missing like the key kind of things that MRTK has provided, such as interaction support, buttons, UIs, things like that. And so you would end up with a lot of extraneous stuff, and it got pretty confusing to make sure everything was behaving as you expected. So even after you got all of that working, MRTK still existed as a separate package beyond the frameworks that these platforms themselves provided. And so in order to integrate with MRTK, we ended up having to create some integration scripts. Those would have to get updated as new packages came out and new APIs changed. Even beyond that, right? MRTK, in order to plug into our interaction system, you had to have data providers who actually read the input data, and even to read what was going on with the controller, you had to have these MRTK sets of controller mappings. And all of this work like multiplicatively increased our scope, right? Every new platform that came in, we had to have a new set of things to like integrate, make sure it worked on there. And sometimes it got out of date. Sometimes it wouldn't work with the latest. It wasn't the best time.
So yeah, our goal, really with adopting OpenXR and Unity's input system basically tries to move a lot of that sort of at a lower layer of the stack, so that sort of everything just kind of works out of the box for you. We can depend on our partners at Unity, our partners across the industry working on their OpenXR runtimes, and really just kind of work together and not have to sort of put all of this into the MRTK bucket. And yeah. Part of this is, we've mentioned the input system a couple of times, but we'll talk about this later, but Unity's created a really nice extension point for mapping directly out of OpenXR runtimes and into the Unity input system. And really all of this, adds together to just let MRTK focus on our strengths, building, great interaction models, great UI UX, and allowing kind of the cross-platform to be handled by, the engines and the people that really want to work on and are good at cross-platform.
Yeah, so some of the great cross-platform things you'll see with OpenXR, and we'll cover this more in depth later, right? But things like hand joint tracking, which both let's say HoloLens, Leap Motion, and Quest provide. Before, those would all have to be separated into, like Oculus would have their own SDK package you would use and fetch the hand joint tracking. HoloLens might have its own. Ultraleap might have its own. In V2, we kind of hook these all together via a bunch of MRTK-specific scripts. Now, with the power of OpenXR, these platforms are able to implement their own kind of extensions to the OpenXR pipeline. All that gets fed in and is kind of abstracted away from the end developers there. And then MRTK can just read that. And we don't have to do as much maintenance. And then, as Curtis said, we can focus on what we do best, which is our UX and UI stack. But hand tracking is not the only thing we got in there. Interaction profiles for controllers, consistent like input actions. So if you have a poke point on your hand, how is that map between like a hand and a controller? Those things are coming in through OpenXR, and even things like runtime controller models. Those sort of things which do not have to be platform specific can now all kind of be joined together and all interpreted and ingested in the same way via MRTK.
So yeah, a key piece of this puzzle, we've been talking about OpenXR integration into Unity. It kind of currently exists in a couple layers. There's, Unity ships their OpenXR package, which contains, the core of it all. The support for rendering, head tracking, a good selection of the interaction profiles. And then we at Microsoft ship this piece, the mixed reality OpenXR plugin, which is where we've done some work to integrate some of the Microsoft specific extensions, as well as a handful of cross-vendor ones that just either make more sense to live in ours or haven't yet been adopted on the Unity plugin side.
Yeah, so how do you get the Microsoft OpenXR plugin? Well, happy to say that it's going to be, if you've been developing on MRTK for the past few months, it'll be through the same thing. It'll be through our mixed reality feature tool with all the good version selection and things that, best ways to keep up to date with how it's going. And once you have it installed, it's really quite easy, and actually we believe that taking in this OpenXR packet, like going down this OpenXR pipeline, will make things much simpler for you as far as a configuration standpoint goes. So before, as we said before, if you have multiple packages coming in that that hook into the XR SDK pipeline in different ways, what you might see is that under the XR plugin management, you'd have two different set of settings: one for Oculus things, one for Windows Mixed Reality things. And the issue here is that if you're deploying to a specific platform, you have to switch between, okay, I need to deploy to Oculus via the Oculus pipeline, I need to deploy to Windows Mixed Reality things via the Windows Mixed Reality pipeline. And merging all under OpenXR, everything is going to be just inside the OpenXR pipeline. And within that OpenXR pipeline, all sorts of features that might be available before might have been available only for one platform, or the other. Like let's say you have some settings in the Oculus pipeline, you're not allowed to use those when deploying to HoloLens because you have to switch pipelines completely. Now that you're only deploying to the OpenXR pipeline, any sort of features which are enabled and pushed there are technically available for any platform that is able to deploy via OpenXR. Obviously, some features won't be available because let's say you're deploying to a device that doesn't have hand tracking, you're not going to suddenly be able to track hands. It's not, it's not built into the hardware. But yeah.
Yeah, and one of the nice things, if you sort of notice on this screenshot, you will see that there is a specific check mark under OpenXR that says Windows Mixed Reality Feature Group. One of the nice things is that just is kind of a declaration of features that it's basically saying I do want to deploy to Windows Mixed Reality, but it's not a checkbox like it used to be, where it's like, oh, if I'm trying to build for Oculus now, I need to uncheck that box. These checkboxes basically represent a concept called feature groups, which we'll get into in a moment. Yeah, really just the mixed reality OpenXR plugin package, just listed kind of a decent number of the actual features that they add: hand mesh, runtime controller models, spatial meshing in planes. Our holographic remoting support ships in this package as well. So it's all kind of the things you would expect that like a HoloLens 2 or our immersive headsets can support. But we do also, we sort of mentioned offhand, we do also ship support for the cross-vendor extension for hand joint tracking. And so this is a cool one, right? Because it's one consistent API in the plugin, and regardless of the runtime you're running on, as long as it supports the hand joint tracking extension. And I sort of put up a brief list of devices and runtimes that I know support it today: HoloLens 2, Leap Motion, the Quest, the Vive. I believe Vario does as well. I think there's a handful of other ones, but it's just like instead of having to import all of those integration packages like you used to, and calling one API when you're running on one device and another when you're on another, it's now just kind of one device coming out of the OpenXR contract. Yeah, so digging in a little bit more there. We've built the mixed reality OpenXR package on top of a bunch of extension points that we worked together with Unity to sort of fill out and build. And just about everything we do in that package, if you maybe have your own runtime, or just there's a runtime that exists out there that has specific features that we haven't supported yet, but you want to support. It's kind of nice, instead of waiting for MRTK to ship a new version and integrate the new integration package and ship a new version, you can really build this yourself. Mostly in the C# layer. So sort of the core piece of support exists in this concept called just features. If you saw the one of the previous slides, it'll be on the next one as well. There's kind of just a list of features in the XR plugin management configuration API. A feature is defined in C#. It can represent a single OpenXR extension or a set of sort of conceptually relevant ones. And this is basically the the key pieces of actually defining a feature in code here on the right. The key bit is the attribute at the top, where you give Unity a bunch of information about the actual OpenXR extension strings that you want enabled, and you can say which build targets it should actually build and run on, and then Unity takes that, sticks it in their UI, and now you have a much more consistent experience than it used to be in the past. Another piece of this is feature groups. I mentioned that on the plugin configuration page, where we had the Windows Mixed Reality feature group. That's basically just a set of features that are, we tend to use them to group features that are kind of relevant for a specific scenario, right? So if you're under the UWP settings, you'll see a HoloLens 2 feature group that has hand tracking, the feature that enables spatial mapping and spatial anchors and that sort of thing. And really, feature groups are just kind of a shorthand, like a quick shortcut for check this box, and we will enable all of the things to try to help you be successful with that scenario. Yeah,
and this is a theme that'll come up a lot. So this is all defined via Unity's OpenXR, and we want to emphasize this is Unity's definitions. And the reason why this is important is that before, if you were trying to write a new feature, that would get ingested by MRTK, just to I wanted to power, say, speech, but I wanted to hook in MRTK. We did have in MRTK, ways to do that. However, what you would end up having to do is that whatever code you write would end up being MRTK specific. It wouldn't be, not necessarily as compatible if you were to write a separate application but not use the MRTK framework. And so because the OpenXR feature group things is so extensible, now if you're writing something, you don't have to decide, okay, do I need to write this just for MRTK? Do I need to write, you can choose to write it for OpenXR. It will work with MRTK, but also work with, whatever else you need to write. That may just, not even be MRTK specific code. Let's say you wanted to use some other graphics package or something, but yeah.
And sort of a key piece of that story is a specific type of feature, which is called an interaction profile, right? And an interaction profile is really a piece of the OpenXR spec, where it's sort of represents kind of like a well-defined input source, whether it's a physical hardware controller or hand interaction. It's kind of that piece of the, if you think back to the MRTK2 controller mapping profile, it's kind of the piece where, you've defined a controller definition in MRTK2, and it says, I've got an A button, a B button, a thumbstick, a touchpad, etc. Now that doesn't have to be defined in MRTK at all. Whether it's, defined in the OpenXR spec side, which then Unity provides a nice extension point to just say, here's the OpenXR spec piece, and this maps directly to specific axes in the Unity input system, the input action mappings profile. And so, yeah, these are well-defined pieces of hardware, like Oculus Touch, Valve Index, the Microsoft Motion controllers. Unity ships a handful of default ones in their package. We add one for the HP Reverb G2 controller in our package. And yeah, this is really the piece that helps bridge the gap between OpenXR interaction and the Unity input system, right? And then I think we've covered this in previous talks. Once you're in the Unity input system, then it's into XRI, then it's into MRTK3, and the cool piece of the input system is we don't really care where it came from as long as the input system says a select happened or this device's pose needs to be at this point in space.
So yeah, again, this is all kind of iterating on that theme of, if you're writing code that'll support MRTK, it'll also support other platforms as well. You no longer have to, there's not as much, we did have in MRTK2, ways we made it very sensible people could write their own controller mappings. What we found is that many people just didn't have the time. There's a lot of, other things that made it, there's maybe not as specific to support for just simply MRTK, but now because we are built on top of OpenXR, you write that code, it'll not only work for MRTK, but also work for all sorts of other frameworks.
Yeah, it was also just not, like, if anybody in the audience has tried to add support to MRTK2 for a brand new controller type, I think you will attest to the fact that it was, very difficult, if not impossible in some cases, because we had, hard-coded enums in the core of MRTK2 where you had to extend that, and it was just a lot more work than it needed to be. And we tried to obviously make it better over the years, but we never quite got to the point that I think this system is today. So yeah, just going back over interaction profiles again. In sort of that UI where you say I support the Valve Index and the Microsoft Motion controllers, right? We kind of recommend only putting controllers in that mapping that you're going to test, or that you sort of very explicitly want to support. Because what happens when you add things to that list is it then registers a layout with the Unity input system. That's when you're able to specifically map, a button on this controller is select, trigger on that controller is select. And one of the kind of nice things about only mapping the things that you have on hand to test, so that you can guarantee that those controllers and those mappings are a good experience, is that then the Unity's input system sort of tells OpenXR, all right, these are the controllers that we say we support, and the runtimes actually sort of have support for detecting the controller that your users have actually connected and remapping them through the interaction profiles that you claim to support.
Yeah. So just to give like a concrete, maybe like hypothetical example, right? So right now you're writing an application. It's supposed to target, the Quest 1, okay? On your Quest, you have two buttons. You like an A button on top, a B button on the bottom. and your application has those clearly mapped to two different actions. Let's say, 10 years down the line, a Quest 20 is available. The Quest 20 has 10 buttons on the top, 10 buttons on the bottom, and your application, you don't want to rewrite that application to be like, okay, these top 10 buttons need to map to this action, these bottom 10 buttons need to map to another action. The beauty of using these interaction profiles is that the Oculus knows that, hypothetically, that Quest 20 top 10 row of buttons maps to the first button on the Quest 1, the bottom 10 rows of buttons maps to the second button on Quest 1. And so the developer knows that, between different iterations of hardware, how to sort of emulate an old controller on a new controller. And because it has that explicit mapping, being able to specify in your application, I work on this set of controllers, then you leave it on the hardware side to let them best understand how to map, okay, here's a new controller you had no idea existed, but it will neatly conform to the spec of this older controller because we, the controller creators, know what the best way of mapping those things are.
So yeah, this really all comes together into the Unity input system that we've sort of mentioned interspersed throughout this presentation so far. This is kind of the key additional piece that is very, very similar to the MRTK2 controller mapping profile, but a little bit in reverse, right? If you remember the MRTK2 controller mapping profile, we had the big block with all the big buttons that had, some of them had controller pictures on them, some of them just had the names of the controller. You'd click that, you get another pop-up that said oh, all right, this controller's got a thumbstick, a touchpad, and a trigger, and then you could map that specific controller to specific actions. The way Unity's sort of action mappings work generally is you're able to do that in reverse. You define your actions, then you're able to go in and say, okay, this action represents this list of buttons on these various controllers. So it's sort of a little bit backwards from MRTK2, but I think it logically just is quite nice to see all of the controllers in one list instead of having to click that button and double check that it's mapped, click that button, double check that controller's mapped. It's just a little bit more intuitive.
Yeah, so if you're familiar with how games do controller mapping these days, right? Back in let's say the early 2000s, you would deploy, you would have a game, you would have the controller on the screen, and it would be like, okay, X button maps to X action, and that's kind of how MRTK2 approached things. But a lot of games these days, right, they will actually list, okay, you have all these different actions. What button do they map to? And Unity's input system more reflects that style. And in this age where different controllers can be kind of put in to you can have any kind of controller working on your kind of application. That's sort of philosophy that this paradigm helps enable. And it also just helps in general understand, because what's important for the game, right? It's not that all buttons have something assigned to them, but rather that all actions are accounted for. And this sort of philosophy, I mean, obviously is Unity's input system. We're not here to explain everything about it, but we believe that going on to this pattern helps us ensure that you are getting what you need to happen in your application working on your controllers.
And we do ship a default set of these action mappings in MRTK3. And so, by default, you should just kind of be able to, hit play and get running. But if you are looking to add, support for specific controllers or to do some remapping a little bit, you'll become familiar with this sort of input action mappings page. And I mentioned before, when you add that interaction profile to your OpenXR settings, that triggers a code path that registers the layout with the Unity input system itself. And then you'll start seeing these sort of little names with OpenXR in parentheses at the end of them pop up. We've kind of, between Unity and us, we've kind of tried to be consistent to make it obvious when, when certain controllers have, old OpenVR mappings as well, just to make it obvious that you are correctly mapping against the OpenXR ones. So yeah, that's just kind of something to look out for.
And the beauty of this system too, right, is that you see they're all ordered in a list. This also provides just a neat way of being able to fall back and understand that, hey, look, I don't have this controller with me necessarily right now, but I can fall back onto this controller button on a different platform. So this is something that is, if you were trying to make sure this was, consistent back in the old MRTK2 UI, you would have to okay, I need to open up every single one of my, controller mappings. I got to make sure that, across every single platform, this is accounted for. But here it just makes it very clear. Look, I have these actions. They need to be supported, on as many platforms as they can. And it just helps. It definitely just helps keep things more organized. Helps you understand that. Look, every one of my actions when I'm trying to run this app will be accounted for. And I think it also avoids situations where you may have an action that's not necessarily bindable on a button for an old platform, and then you can very clearly say, okay, this specific action is not accounted for on this controller. Maybe it's missing a button, but you can develop another workaround that maybe use a button macro or something that would be not as easy to specify or flexibly create via our older UI.
Cool. So next we're just gonna jump into a quick demo just to show off some of the cross-platform extensibility that we've talked about in here. So yeah, we'll get that set up real quick.
Yeah, just hold on, folks. And so this is going to be really exciting. Well, relatively exciting, because you'll see just how quickly and how efficiently we can switch between our different runtimes. So what we have here is our MRTK 3 project. My lovely assistant Curtis here is putting on the HoloLens, and we're going to do something that should be familiar to most of you, which is going to be holographic remoting. So holographic remoting on HoloLens, you've opened a remoting window, holographic remote play mode, you enable it, and Curtis here is pulling out application in order to actually remote into the device. And you'll see once I hit the play button, and not yet. No, not yet. What are you waiting for? Okay. We'll have to wait for the hardware to spin up for a second. Any second now. You'll be happy to know that this is MRTK code that's causing it to run slowly. It's just a matter of, you got to log on to your computer and whatnot. All right, cool. So, holograph remoting basically is a very fast way, in case you're not familiar, of being able to emulate your HoloLens's input and basically connect directly to your input action system. You see the game view. It's a little bit obviously first person, very confusing, but if I pull over to the scene view, you have his hands moving around in the field of view, all the hand tracking, everything. You even have our new gaze controller, because HoloLens does support eye tracking, and you can pick up objects, rotate them around, all the natural good things. You've probably seen this before. You've seen it in demos. It's this is something you would expect from MRTK2. However, now for our real trick, we're going to show how quick and easy it is to get running on the Oculus Quest.
So yeah, while Roger's setting up Link there, I just kind of wanted to call out a couple pieces here. Sort of first, just disabling holographic remoting, since we're on a Quest now. But if you have used MRTK2 and you're familiar with all of the data providers that we used to have for input and all of that, just to show you that we're not doing anything magic in the background for getting hand tracking working across these two. The hand joints really come through these hands subsystems in MRTK3. So you'll see we've got two currently checked. One is our subsystem for hand synthesis. So if you use our in-editor simulation, that's where we sort of provide you a fake set of joints that will animate as you click the buttons. But as far as across both the Quest and HoloLens 2, this subsystem for OpenXR Hands API is the subsystem. It's talking to the same API regardless of the device we're using here. And then it just talks to the runtime and gets the data out. So there's no this needs to run on Android and this data provider needs to run on UWP. It really is just this subsystem.
I just want to emphasize, in addition to that, so before on MRTK2 we had all the different data providers running, and you were allowed to have those data providers running whether or not they were actually used. And so MRTK2 was performant, perhaps not as performant as it could be. And part of it might have been due to some of the data providers, running in the background. Because of how OpenXR's feature groups work, if your feature's not being used, it won't be running. And that sort of performance bottleneck, that sort of performance tax is not going to be as apparent. But I think we are almost ready. As you can see, I was not really interacting with the Quest, so not too much configuration was needed there. But here we are. We're going to be in the view, and go ahead, Curtis. I cannot see and talk.
Oh, yeah. So, I mean, yeah. Here, take like a step or two forward just so your hands are more. Yeah, there we go. Yeah, so if you see here, it looks the same, which, maybe isn't that exciting, but that's kind of the I don't know, in my opinion, awesomeness of it, right? It is the same. It's the same API. It's the data this time the data is coming from the Oculus runtime. Previously, the data was coming from our holographic remoting runtime. The MRTK doesn't care, which device you're talking to, as long as, the OpenXR contract is fulfilled. So, and we had also heard that some people had some issues getting Oculus Link running properly with MRTK2 in the past as well, which is much easier in MRTK3 because of just the way the OpenXR runtimes are all configured. So yeah, that's basically the demo. I mean, yeah, it's just a quick switch the USB cable between devices. We kind of just disabled holographic remoting, hit play again, and now it was on the Quest. So yeah, that's basically everything we have for you guys today. Hopefully, yeah, it's been a fun long journey from Holo Toolkit and MRTK2 and all of the cross-platform work across integration packages that we did in MRTK2 to see a lot of this come together across the industry through OpenXR and getting our friends at Unity on board with helping us come through. And yeah, I don't know, it's awesome to see it all come together.
It's a constantly evolving story too. Work's not done, and we're still working on delivering great new cross-platform things. So. Develop once, deploy to lots and lots of places. Hopefully write less redundant code, and hopefully break less when other things get updated. Yeah.
Yeah. So thank you. I think we've got a little bit of time if we want to open it up to Q&A. If anybody has any questions. If not, that's cool too.
Yeah. We have a lady over there.
So a quick comment that my coworker Don just brought up after seeing how easy it was for you to switch between Oculus and the HoloLens was that you could theoretically utilize MRTK to prototype for HoloLens on the Oculus Quest, kind of using what we just saw there with the pass-through video with the hand tracking if you didn't necessarily have your own HoloLens. Is that kind of correct? Would there be some pitfalls there if that's the pathway you took?
I'd say that's generally correct, right? Like, you're depending on the features you want to use, right? Like if you're trying to use, like spatial mapping or spatial anchors or things like that, that just don't exist as like cross-vendor extensions today, then, you may need a HoloLens device to build those parts of the experience. But if you're really looking for like, the input and interaction and tracking parts of the experience, yeah, I mean, right, like it's coming across the same OpenXR API, so you've got the same set of 26 hand joins regardless of the device, coming through with, a consistent sort of spec-defined like rotation for what Y up should be. And yeah, the intent is that the experience should be, very, very similar and familiar.
Yeah, so like, there's various layers of development stack. You have input, and thankfully a lot of the whole just ingesting input is handled by OpenXR. Then you have interactions, which, we're leveraging a combination of XRI and MRTK code in order to nicely do that. And, I think if you've attended a previous talk, interactions also aren't necessarily MRTK only. You can incorporate MRTK with perhaps your own interaction building blocks built on top of XRI. But fundamentally, all the stuff that MRTK has excelled at in the past, which is our UI interactions, all that stuff will work the same regardless if you're on Quest or on HoloLens. And that is one of our key parts of the development story. We want to make it easier for developers to develop MR apps as best they can on the most convenient device that they can access. Another question over in front. Let everyone else hear.
So I know over the last year, hand tracking support on the Quest hasn't always played so nicely with MRTK. There's been some MRTK versions where it's worked really well on, and then it hasn't worked well on others, and OpenXR kind of threw a wrench in the system. Does MRTK3 fix all that, or are there still some known issues?
I would say it absolutely fixes all that. Like a lot of the, I mean, Roger can talk a little bit better to this because he's, one of the key pieces of getting some of that Oculus hand tracking in. But there was, some amount of building on top of specifically the Oculus integration package, where we had to, work around some of the ways that they intended things to be implemented in Unity, whereas now we're able to really just get at that data more directly and pipe that just right up into MRTK.
Yeah, the OpenXR story formulating really did help kind of, cement and create something consistent across, multiple iterations. So yes, before you had to, import the Oculus integration package, hand tracking was only available via the Oculus integration package. And that actually became a difficult point for us as far as, maintaining compatibility and maintaining, up-to-date parity with each version, because their update schedule doesn't necessarily align with ours. And having to keep on going back and be like, oh, okay, they changed some enums here, they've changed the API here, we need to update our integration scripts. That became kind of a pain point. So because we're able to always reference these joints via the OpenXR runtime, it really does help smooth all that out. It helps make sure that developer experience is smooth. And it definitely, reduces just like those kind of lapses where, it's suddenly not working because the integration package updated, but MRTK is not ready to update because we have, some new features coming in. So yeah, definitely should be a lot better, even beyond just, Quest support, other platforms like Leap and whatnot. As long as they, use OpenXR, we'll be able to leverage it and not break as much.
Yeah, and Roger mentioned Leap Motion, Ultra Leap. That another we waffled on maybe demoing that as well as like a third device as part of it because they ship their own OpenXR API layer, which just talks directly to their hardware and goes through again the exact same OpenXR API. So if you were using Leap Motion and MRTK2, that's another one that had their own integration package, which contained the pieces that would talk to their hardware and bring that into Unity. And now because they have that API layer, it's all through OpenXR. You install the API layer, you hook up your Leap Motion hardware, you put on your VR headset with the little mount on the front, and you hit play, and just like sort of those demos, you'd get hand tracking. Yeah.
Question in the back?
Going one question before that one. So when you're emulating the Quest, with the Quest, right?
Yeah, we're using Oculus Link in order to directly interface with MRTK or with Unity.
Is it possible to use AR Foundation through that?
Curtis,
with the objective of using the image recognition.
I don't have a solid answer to that. I'm not sure what specifically sort of AR Foundation and then the Oculus implementation of AR Foundation, how that does or doesn't work over Link. I don't know. I unfortunately don't have a good answer for that. I haven't tried that out. But I mean, as far as I can't talk to Oculus, I can talk to the HoloLens. If you're using like the AR Mesh Manager, you mentioned specifically the image one, but there are pieces of AR Foundation like the AR Mesh Manager, the AR Plane Manager, that you can use over like holographic remoting through those OpenXR APIs. So it kind of all, it depends on the implementation at that point. And unfortunately, I can't speak specifically for the Quest.
Gentleman over there.
Thank you very much. So two questions. The first of which is I'm a MRTK newbie, but I understand very much where it's going, and I sort of go all the way back to the Oculus days. Is this a circumstance where MRTK is going to ultimately target platforms like mobile devices and also tablets and also smart glasses in the future? And would MRTK be the thing that would automatically degrade the app to fit the platform, or would that principally be the developer's responsibility to say, here's what's allowable?
I think that is definitely something that we've been thinking about, right? I don't know if you saw, it was one of the first talks with Grace and Brent where they talked a bit about the MR Playground app, or sorry, Zappy's Playground. And in that, we had some UI that did adapt for, you know, whether you were on an AR see-through device like HoloLens 2, or you were on an immersive VR device like the Quest, it would bring in additional sort of pieces of the world or slightly change the UI components just to adapt to that scenario. So that is definitely something that we're thinking about, and I think there's absolutely a broad range of devices that you know we have, you know, tested and support today, but also that we're kind of thinking about supporting in the future. So yeah, absolutely. Like I think for a you know, spatial UI and UX framework to succeed, supporting as many of those endpoints as possible would absolutely be a goal.
Yeah, just jumping on to like MRTK's role in sort of all this stuff. MRTK is, you know, built as a UI UX sort of toolkit, and you know, one of the things that we've, you know, mentioned is that because we're allowed to build on XRIs, things like, you know, if you were on like a 2D device, we have interactors and components that'll let you translate things like mouse inputs into a sort of AR equivalent 3D input. So if, you know, you're looking at a 3D button that you might want to click on in like, you know, 2D space with a mouse click, but also push with like your physical finger in a AR or VR space. Because everything's built on top of XRI, we do have the capability of, you know, being able to work cross-platform, quote-unquote platform in that respect. Things like OpenXR help a lot with, you know, making sure input works across different like exciting kinds of devices. You know, you have all different kinds of controllers. But one thing that, you know, OpenXR being built on top of Unity's input system allows us to do is, let's say you have a traditional, let's say, Xbox controller. That thing, you know, you can hook up the input actions from the Unity input system to the Xbox controller as well as AR and VR devices. And it will all kind of, you know, inside the application world behave in the same way. A button is a select whether or not you're pinching with your physical hand, whether or not you're clicking or using a touchscreen, whether you're pressing an A button on a controller, all of that kind of all loops together. And it's really tied into the theme of, you know, there's kind of one source of truth, and we're, you know, all kind of trying to follow the source of truth and encouraging developers to, you know, also fall into that sort of pattern and, you know, basically be as compatible and deployable across as many things as possible.
Thank you.
We have a gentleman up here.
Thank you for a wonderful presentation. With Microsoft supporting the Qualcomm Spaces initiative and SDK, have you guys at all tried out the MRTK3 with the Spaces
I have
platform?
not. Yeah, sorry. Yeah.
Yeah.
Yeah. Not yet. It is something that's kind of on our radar, and we've heard that pieces that are also, you know, built on XRI and have XRI support. That it feels like a very natural place for us to see how it all works together. But yeah.
One of the pieces that I'm interested in is the controller with the Qualcomm reference design is actually the phone, because whether it's tethered or not, how is the controller model being translated to use a phone instead of your hand gestures or a controller?
So the thing that on the controller compatibility standpoint, we've mentioned interaction profiles in this talk, and before, I think as we, you know, in MRTK2 land, we would have had to, you know, take a look at that Qualcomm controller, figure out, okay, which parts of this controller map to which sort of actions, and write a lot of, you know, controller mapping things ourselves. And well, not necessarily ourselves, we would have the API for Qualcomm to perhaps do it. But because it would be tied to MRTK, I don't think maybe they would have been incentivized. We'd have to rely on open source community and things like that. But because the interaction profile kind of is built on top of Unity and is so extensible. If Qualcomm creates an interaction profile just to have their controller recognized by Unity, usable on OpenXR, MRTK can then say, hey, this Qualcomm interaction profile exists in the world. We can add it and then once you have that, that interaction profile in there, you can kind of recognize the controller inputs. You can map those to the appropriate input actions on Unity's input system. And then once you get past that point, once you have those input actions mapped, it's all MRTK from there.
Yeah, or even just even at a higher level than OpenXR, as long as the phone input is able to go through Unity's input system. I think generally that's something that we need to look into still, but it's all a very exciting space at the moment. So
it's very new for sure.
Yeah. So certainly something that would be awesome to look into.
Thank you.
Come on, guys, don't be shy. Anything else? All right.
Okay.
So one thing that I just keep pondering is the way open standards went in like the web world, where everybody has their own custom extensions in the CSS and such. I'm just wondering if you have any thoughts on how this all might play out as various vendors come up with their own vendor-specific extensions. And do you have any ideas of how that's going to unfold and what the implications might be?
Yeah, so I'm not as directly involved in some of that as some other of us at Microsoft, but from my perspective, I do see a good balance between vendors specifically continuing to iterate on their hardware and things that they want to see happen, and then there's just been a nice sort of collaboration that I've been exposed to a little bit, but have sort of just heard about, where people start bringing their ideas together, and maybe two companies want to accomplish basically the same thing, but have slightly different ideas about the best way to approach it. And things like sort of the hand tracking extension that has come together. It just becomes a good convergence point between continuing to allow vendors to iterate and explore their own hardware while kind of driving the industry as a whole forward with all of this kind of communication of things that we think will be relevant to just developers in general, and without ideally without fragmenting too much on the vendor specific things. But so far I think there's a good amount of sort of convergence on the cross vendor extensions, which is nice.
Okay. If there's nothing else, I think we are reaching close to time. Thank you all for attending this talk.
Yeah, thank you very much.
Yeah.
Thanks.
Hashtag open, deploy once. Go everywhere.
Cool. And we will both be in the MRTK3 panel that I think is next. So if you do end up coming up with any more questions, you can ask it there, or we'll be around. So yeah, again, thank you very much.
Enjoy the rest of your day.